Okay, today we're going to be looking at something called compound angle formulae. Now these are a list of different formulae that we memorise that can be really useful in helping us to solve equations and just to play around with trigonomic identities. So we're thinking about triangles, and we've got this angle here could be split up into angle A and angle B. So we have 6 compound angle formulae, and these are sine A plus B can be written as sine of A multiplied by the cosine of B plus this, the cosine of A multiplied by the sine of B. Then we've got sine A minus B is equal to the sine of A cosine B, this time minus cosine A sine B. So you can see how they're very similar. Then we can have, so we've got, these are the ones for sine, and we've got cosine A plus B is equal to cosine A cosine B minus, so this is, bear in mind that was plus, for cosine A plus B is now minus here, sine A sine B. Then we've got cosine A minus B, cosine A cosine B plus sine A sine B. And now we have the 2 for the tangents. So tan A plus B equals tan of A plus the tan of B over 1 minus tan A tan B. So these are much more trickier to memorise than the sine and cosine. Oh, excuse me. And then we've got the tan A minus B is equal to tan A minus tan B over 1 plus tan A tan B. So these are the 6 compound angle formulae, and let's look at how we can use them in an example. So firstly, we want to find the sine of 105, and we want to find it to an exact value. So what we can notice is sine of 105 is the same as sine of 60 plus 45. So remember, before we memorised different trigonomic identities that we would come across all the time. So if you, when you get something like this, look at the number and see, can you make it as a sum of 2 angles that you know the sine or cosine for. So we now apply the compound angle theorem, so it would be sine 60 cosine 45 plus cosine 60 plus sine 45. Now we know these from previously, so the sine of 60 is root 3 over 2, sine of 45 is 1 over the root of 2, plus a half for cosine 60 multiplied by 1 over root 2 sine of 45. So this will then give us root 3 plus 1 over 2 root 2, and we can't simplify that any further. We want to find an exact value of cosine 45 cosine 12 plus sine 42 sine 12. That's going to be a 2, it's a terrible 2. So we recognise this as the cosines here, sines here, we can use the cosine formula, and that's going to be cosine of 42 minus 12 which gives us the cosine of 30, and we know the cosine of 30 is root 3 over 2. Now, we're given that the sine of A equals 4/5, and the cosine of B is equal to 5/13, where A is obtuse and B is acute. We want to find the value of sine A plus B. So we know that we've got all students trust Cambridge, and we know A is obtuse, so it must be greater than 90 but less than 180, so it must be in this quadrant, and it's 4/5, so 4, that must be 4, it must be 5, and this must be minus 3. And that's, we can work that minus 3 out from Pythagoras. So the sine of A equals 4/5. The cosine of A would be minus 3/5, and the tangent of A is equal to minus 4/3. So we can, this here would be the obtuse angle of A. So for sine A plus B, we've got the sine of A cosine B plus cosine A sine B. Now we need to do the same for the cosine of B. So we know B is acute, so it must be in this quadrant. So this must be B. So this is going to be, the opposite here is going to be 13, this is going to be 5, and again from, it's not 13, it's 5. Let's rub that out and put that in the wrong place. This is 13, it's hypotenuse. From Pythagoras that would be 12. So now we've got the sine of B must be 12 over 13. We know the cosine of B already as 5/13, and we know the tan of B must therefore be 12/5. So we want to find sine AB plus B, that's going to be, so we just slot in what we've now worked out. So sine of A is 4/5. Cosine of B is over there is 5 over, what did I write there? Is that a 13? That's meant to be a 13. That is a terrible 13. 5/13 plus the cosine of A is going to be minus 3/5, and the sine of B is 12/13. Working all that out, we get minus 16/65. Now we want to work out the cosine of A minus B. So again, we just take our cosine A minus B, write down our formula, cosine A cosine B minus sine A sine B. slotting the numbers in that we know we've got minus 3/5, 5 over 13, plus 4/5, 12/13. Tidying all that up, we get 33 over 65. And finally, if we want to find out, I'm running out of space, I'm going to put it in the middle here, tan of A minus B. That's going to be tan of A minus tan of B over 1 plus tan A tan B. I'm actually going to rub this out so we can write it down here, because it's going to have some more complicated working. There we go. So we've got our up here, so we do, that's, finish this off here. So tan of A is this, so it's minus 4 over 3 minus tan of B, which is 12 over 5, divided by 1 plus tan of B, which is 12 over 5, times 12 tan of, so it's tan of A. Let's rub that out, that's my bad writing again. It's meant to be tan of A. Tan of A, which was minus 4/3, and then tan of B 12/5. So we need to play around with these. So we're going to get, so what I would do first is take this top part out. And so that's going to be minus 20 minus 36 over 15, which will give us minus 16 over 15. And then if we take this bit here, we're going to have, I'll write it up here, so we'll have 1 plus minus 4 times 12 is going to be minus 48 over 15, and then that will be 15 minus 48 over 15. So it's going to be minus 33 over 15. So what we end up having here is going to be, we have two minuses which will cancel each other. So we'll have 16 over 15 divided by 33 over 15. The 15s are going to cancel out, so we'll end up with, I think I've messed up my, I have, that's not 6, minus, that's going to be minus 56. Sorry, that made no sense there. That'll give us 56 over 33. So with these ones, take your time in sorting out your fractions, because that's where you can really trip up. Finally, solve sine 60 minus x equal to 2 sine x for 0 less than x, for x between 0 and 360. So we're going to expand sine 60 minus x using the compound angles formula. So it's going to be sine 60 cosine x minus cosine 60 sine x equals 2 sine x. We'll replace the sine 60 and the cosine 60 with root 3 over 2 cosine x minus half sine x equals 2 sine x. Now we're going to multiply through by 2 to get rid of these halves. So that'll give us root 3 cosine x minus sine x equals 4 sine x. And now we'll bring, it's just a simple playing around with our formula. So let's bring this over here. So it's going to be 5 sine x. And then we're going to rearrange this to get root 3 over 5 equals tan x, and so that's going to give us x is equal to 19.1, or because it's positive, remember all students trust Cambridge, so it must be in this quadrant, so it'll be 180 plus 19.1, which gives us 199.1 degrees. So I hope that helps.